Hi, this is Bill Ragsdale, K6KN in Woodland, California. I'm the president of the BARC Amateur Radio Club, and we manage the KE6YUV repeater. This is the first of our series of 5 presentations on the management of repeaters. So let's go to the screen share and we'll start the program immediately. So here's what we'll get over the next 5 weeks. There'll be 5 sessions. They're going to be a hands-on opportunity after that. The sessions are going to run about 45 minutes for the program, and then about 15 minutes of question and answer following that. These Zoom videos are going to be posted on my YouTube channel, which is K6KN space Bill. And you're all invited to the BARC Slack site for your questions, your answers, postings, and schedules. And you'll get an invitation of this by email. The address is ke6yuv.slack.com, or you can contact me individually and I'll give you access to that site. And when you reach that site, be sure to change your personal settings to be able to receive notices. People will come into this site, register, and not receive notices, and then not come back and realize that the program is going ahead without them. And the PDF slides of this presentation will be posted on Slack. As I said, the videos are going to be on YouTube. So what are your responsibilities in being a student in this series? Well, to get the most from this class, I really ask that you get a spiral-bound college rule notebook. That's the ones with the narrow lines. And record everything associated with your activities on repeaters, both what you've learned in the class and when you do hands-on a repeater. Record everything, because you'll come back to your situation maybe 3 or 4 months later doing a visit to a repeater site, and you've got to be able to remember what the changes are from last time. As you can see here on my notebook, I've filled about 50 pages so far over the last couple of years. There's hand diagrams on the left, a lot of notes, and then the blue squares in the center are photographs of a service monitor for actual measurements. And we have an assignment for each session, which leads into the next sessions. Your assignment for this session was to get that logbook. I hope you've done it. And also that you downloaded the PDF of the BCR 50V repeater. This is the repeater we're currently using on our site. So as a summary on our sessions, January 10th, this session, we're covering repeater management and operation. January 17th, it's going to be components and functions. January 24th, we'll get into the technical aspects, how to make measurements. January 31, we'll do a deep dive into test equipment. And in February 17th, we'll talk about troubleshooting, what can go wrong. And then finally, we have hands-on optional training. So a little quick introduction. I was first registered at the age of 15. I only kept into ham radio for 1 year because the license was non-renewable, and I went on to other things. And 50 years later to the month, I relicensed in 2005, and it's been a great time ever since then, recovering all of my ham experience. As a disclaimer, I only know what I know. I've been operating this repeater for a couple of years now, and I've been on the BARC team for about 15. I know what I know, but there is much more on repeater technology that I do not know, so I'll be humble about that. I've maybe got about 70% of the top technology covered, but the other 30%, some of the details on advanced repeater use, on feed lines, the coax lines, and so on, installation work. And I hope to rely on other people to add that information. And we'll have time for questions at the end of this session. So today, repeater management, and next week we'll pick apart each component. So let's see a repeater in action. This is a view from 5,000 feet of our KE6YUV repeater in Northern California. The lake is Berryessa. On the left is Woodland, and immediate left is a city of Esparto. We're now at about 1,000 feet coming down, about 500 feet. This is our helicopter view. We're getting to about 200 feet, 100 feet, and now we start to get a direct view of our repeater. and will be here at about hovering at 100 feet. On the left is an old AT&T relay site that's now turned into commercial use. This site is at about 3,000 feet overlooking the greater Sacramento area valley. This is our vault. We have 1/3 of it. The other 2/3 is a commercial site. This was put in by the county about 40 years ago. It's passed through a number of hands, and they allow us as a public service group to operate here at no cost. The antennas you see are primarily ours. So the first view of what a repeater looks like. Now this one is done with 2 antennas. We'll talk later about what a site is like that only has 1 antenna. At the left, a little crow's foot up in the air is our receive antenna. It goes through 3 filters. We'll talk about this in detail. Into the receive side, the RX side of our repeater, the modulation is converted back to audio. That then remodulates a carrier on a different frequency for the transmit side, and then it goes out through the filters and up to that antenna. At the bottom, we see our power sources. We are using utility power from Pacific Gas and Electric. We have a deep discharge battery that has about a 5-day supply of power for us, and then we have a solar charging for that assembly. And here is our antenna set. The receive antenna is at the highest elevation on top. This is about an 11-foot long dipole antenna, not dipole, but a ground plane antenna. Our transmit antenna is at the bottom right, and at the bottom left is our packet station. From our diagram a moment ago, remember we saw the input filters. These are the 3 telewave filters. The 2 on the left are bandpass filters. The one on the right is a notch filter. It's set to reject our transmit frequency. Then we have our repeater. The upper repeater is a Hi-Pro Maggiore repeater we bought in 1995, and it, as I say, it is a workhorse. It has been doing a wonderful job. We added a controller board to it a couple of years ago that does voice output, but it is a beautiful machine, and it talks to us. The BridgeCom at the bottom was put in service about a year ago, and it is a completely packaged repeater, everything integrated into one box. We've had a little bit of trouble with it. The manual is, I would rate, as rather poor, and a couple of errors in the manual have required us to actually send the repeater back for service when it was not required. I wish they would do something to improve their manual detail. Upper section is the Astron 25 amp power supply. It puts out 13.8 volts to power the station. It's essential to have the meters on here, because when you're troubleshooting and you're at 3,000 feet in a cold, semi-lit vault, it's nice to be able to glance at those meters and see what the power is doing. At the bottom left is an EPIC power gate. This integrates our power. It takes the battery input, it takes the utility power input and the solar. It regulates the charge of the battery and then does a no-break switch between the power sources. We were having some dropout problems on the repeater, so we put a low voltage detect. The module at the right is a brownout detection. If the supply voltage drops below 11 volts, it gracefully shuts off the repeater. When the power comes back, it very gracefully restarts the repeater. And this is our transmit cavities. These are Phelps Dodge. They are from 1972. They are a workhorse. They, as we had before, there are 2 of them are a passband on our transmit side, and 1 is a notch reject on the receive side. And again, our antennas. Now notice we have 2 separate antennas, so we get a great degree of isolation from the transmit to receive side just by having 2 antennas. This is a view of the inside of our vault. The gray cans on the left are those Phelps Dodge, and then way over on the right are the telewaves that are our repeater site, and the repeater itself is a little out of view on the bottom. It's not too neat. We really need to do some housekeeping here and get those cables into some cable trays. All the power wiring is very nicely covered. So first, some key terms about repeaters, which we'll be using over and over again. The first is the concept of the frequency pair. There is a standard plan for repeater allocations that's used in the United States. We transmit on one frequency, and then for 2 meters, we receive on a frequency 600 kilohertz away. When you set a transceiver to the receive side, it will automatically know the transmit frequency. This is called the offset or the split. The separation between those frequencies for 2 meters is 600 kilohertz, and on 440, the separation is 5 megahertz. The next step is the CT-CSS. This is Continuous Tone Coded Squelch System. In the Motorola world, it's called PL. And this is the tone that is continuously transmitted by all of our client systems in the field, so the repeater knows when to properly unsquelch. The channel spacing, as I mentioned above, is 600 kilohertz, and the deviation is the bandwidth occupied by the transmitter. In the case of ham radio, it's 5 kilohertz. And finally, the concept, or the element here of NARC, N-A-R-C-C. That's the Northern Amateur Radio Coordination Committee. They coordinate the frequencies. We'll talk a little bit about that as we go along. And finally, SLAC. This is our web-based class support site. So, step one, why a repeater? Well, this allows portable and mobile stations to access a wide area. If you have an HT, you can go between 3 and 5 miles. If you have a little rooftop antenna, you probably can go 10 miles. But when you go into a high-level repeater such as ours, we have a radius of 125 miles. Well, from one edge to the other is about 250 miles. And we blanket the better part of Northern California because of our 3,000-foot elevation. Another purpose of the repeaters is to serve as a backup for telephone service and emergency communications. ARES uses our repeater. It's also used for bike races and for other events, foot races, and so on. It's also is available for use by Red Cross and ARES for emergency service. And finally, we build a sense of community among the hams. We sort of think of this as Facebook by radio. We have 3 nets. We have 2 Sunday night nets. We have a Monday net. And then every morning at 7 a.m., there's a half-hour coffee and commute time chat net. An obsolete detail. Years ago, back in the 70s, 80s, and early 90s, before cell phones came along, amateurs could tie in a telephone line to their repeater and then use their handy-talkie or their mobile station through the keypad to dial telephone calls. And it was a very handy feature where we had car telephone service well before everyone else. With the advent of cell phones, this has pretty well fallen into disuse. What do we need to make an effective repeater? Well, first we need elevation and shelter. A rooftop system may go 10 miles. If you're on a 5-10-story building, you might go 20 miles, but you really need elevation. Of course, the solid equipment, the repeaters and the filters, it's a one-time purchase and a one-time setup, but it's the core of your system. The antennas, and again, power, we've mentioned before, utility, solar, and battery power. You also need a supporting organization because there are expenses on this, and you do need people with specialized skills. Operating a service monitor is a fairly advanced skill. Climbing towers is another. So it's great to have an organization. And you need a clear frequency pair. We'll talk about that in some detail. And finally, you need a website so people can find your frequencies, your split, your CT-CSS. And it brings in members to the organization. Now, there are a few reasons why you should not create a new repeater. There are hundreds of repeaters in the Northern California area with essentially no traffic. There's about 20 repeaters that get the bulk of all of the traffic. Our local high elevation repeaters is K6MVR at 3,000 feet on Mount Vaca, N6ICW on Snow Mountain, that's not quite as high as 3,000 feet. That's N6ICW is at Berryessa Peak at 3,000. N6QDY at Snow Mountain, a little bit lower. KE6YUV is our repeater, again at 3,000 feet. And then we have WD6AXM, which is located north of here on Sutter Buttes. These all have good coverage because of the elevation. There are several other repeaters which support clubs. They're not quite as high in elevation. Their coverage is a little bit less, but they have a good membership base that they're supporting. And as I said, if your antenna is rooftop level, you'll get a 10-mile circle and no one will come. More reasons. It's in Northern California, it is impossible to get a 2-meter coordinated frequency pair. They are all allocated. You might consider the 1.25 meter band, that's 220 megahertz, but on that frequency or that channel again, and nobody uses that band. Operating the repeater or setting it up initially is a little expensive. It's about $4,000. If you get used equipment, which I do not recommend, you could do it for about half of that. And if it becomes more elaborate, the budget could be a good bit higher. The running cost is anywhere from $0 a year if it's in your own shack, to about $1,000 a year if you have purchased utilities, if you have insurance, and then you budget for maintenance and improvements. But here's what you can do. What you should do is, if you want to get into the repeater support activity, find an existing repeater and join the team, because repeater teams are always looking for new people. You can learn, you can enhance your skills and make a contribution. Here are some of the key terms associated with a repeater. The keyword is duplex. Duplex means transmitting and receiving at the same time. The old wireline telephones were full duplex. It meant that you both could talk one to the other each end, and you would hear each other simultaneously. The advent of cell phones moved us to back a step to half duplex, which means only one person talks at a time. If you're on a cell phone and you start talking and the other person interrupts, it shuts down your voice flow and turns the channel around so the other person talks. Now, Zoom is essentially the same way. Whoever's talking the loudest on Zoom takes over the channel and the video. Simplex is one way only. This is like television station. You do not talk back to a television station. You may yell at the TV screen, but they can't hear you. This is a misuse in the ham radio areas, because we often say it using a handy-talkie to talk to someone else. We're talking simplex. Well, we really aren't. We're talking half duplex, because only one person can talk at a time. So that is just an element that we just have to put up with. Next term, bands with repeaters. To my surprise, FCC allows amateur radio repeaters to be from 10 meters and above. I don't know anybody that has a 10-meter repeater. These days, with a good sunspot cycle, you can talk around the world on 10 meters. I don't know why you need a repeater. But historically, there have been repeaters on 6 meters, but the core of repeater use is on 2 meters and 70 centimeters 440. There is an increased usage on 900 megahertz, but the transceivers are a little hard to get a hold of. Most of them are repurposed commercial units. The modulation methods. Well, the anchor for all of this is FM transmission. That's been the basis since the 1950s when I started. The current modulation methods that are beyond FM are digital. There are three primary digital methods. Yaesu has what they call Fusion, ICOM has D-Star, and the DMR is Digital Mobile Radio, which is a takeoff from commercial services. There are strong regional preferences. I find that DMR is used very heavily in the Denver area. I have a relative up there, and they use 440 and DMR. In our Sacramento area, we're precluded from using 440 megahertz because we're a secondary allocation to a military base. So we're primarily on 2 meters and primarily on FM. I believe there is one Yaesu fusion station in the area. A great expansion for repeaters has come through internet linkage. There's a number of ways they link. Sometimes they are linked by RF. You'll have back channels on 2 meters or 440 linking repeaters together, but the more common use these days is by internet. The internet techniques, the first one is called Echolink. This is very flexible, very available. It operates on cell phones and easy to add on to a repeater, even if you do not have internet at the site itself. IRLP was a precursor. I believe it was the first digital one that hams were using. It's internet radio linking protocol. It requires a special board put into your computer base, but it is extremely reliable. The combination came along of Echo IRLP, which the two together. Another entry in the race is All-Star, and then we have iLink. Wires is an analog FM version done by Yaesu. D-Star, as I said, is by ICOM, and DMR is linking. I believe it's derived from commercial use, Motorola in particular. There is a lot of detailed notes on the internet, so I suggest you research them on your own. And if you do have questions, go to our Slack site and post your questions there. So let's talk about band plans. The band plan is the method of sharing the frequencies, because as we know by law, we do not have exclusive use of frequencies, but if we spread them out, we can find a little place to plant our equipment. You see here, the green arrow is our KE6YUV transmit frequency, and its receive frequency is the red arrow, and they are 600 megahertz apart. Each transmitter pair also requires a CT-CSS tone for reliable operation. The offsets are automatically placed on ham radio base stations and HTs. However, some stations have reverse offset, and K6MBR is the case. So if you were to set up for a K6MBR repeater, you realize you would take the setting that's in the HT and reverse it. And frequency repairs are coordinated or assigned by this group, NARCC. We'll talk more about that in a few moments. So a legal summary. As I mentioned before, you can have a repeater on 10 meters and above with a specific on ham frequencies, with some specific exceptions. There are sections set aside for simplex, for remote control. There's even a section for remote control of aircraft, of hobby aircraft, and satellite communications and so on. So you will know when you have your proper frequencies, when you're able to be coordinated by NARC. In other areas, there are similar coordination groups authorized by FCC. You also need a control operator. FCC says that you should be able to mute the repeater in case of malicious interference 24 hours a day. Although I really don't know repeaters that have 24-hour monitoring in use. I do feel, though, that one of our control operators will probably get a telephone call late night if there's abuse on the repeater. And so you need to be able to mute the repeater remotely in case of malicious interference. And the controller has to do a timeout in case of a stuck mic. The typical case is after 3 minutes of continuous signal, the repeater will mute until the input carrier goes away. So if your mic is stuck or someone is long-winded and talks for 5 or 10 minutes, they'll be cut off after 3 minutes. As soon as they release the carrier, the repeater will go back into operation. And of course, you're required to identify within 10 minutes of use. It's either done by Morse code or by voice. A typical repeater will ID after when there's a break after 9 minutes. If there's no break after 9 minutes, it will go till 10 minutes and then overlay the ID on top of whatever's communication going on. So good old NARC, Northern Amateur Radio Relay Council of California. I respect them deeply for the work they do. It's volunteer. They get flack when there are coordination disputes, but their word is final when it comes to FCC. We'll talk about that in a moment. They assign the frequency pairs and the CTCSS since they maintain a database of all repeaters in the area, and they look at your elevation, the surrounding area, and the CTSS tones in use, and will either suggest the proper unit and issue coordination. Repeaters can be coordinated and uncoordinated. Uncoordinated means, though, that you are not sanctioned by NARC, and if there's a communication problem or interference problem, the FCC will accept NARC's judgment upon a complaint, and if you have repeated violations, the FCC will send you a nastygram and possibly $10,000 fine. So if you have a repeater at a high elevation, such as we have, if you're communicating with a handy-talkie, a small portable station, you're outdoors, your coverage is good to about a 60-mile radius. In our area, we get not quite to Oroville in this condition, and we get down almost to Stockton. To the west, we have very limited coverage because there's about 70 feet of hill behind us toward the west. So it shields us a little bit from the west, but we get very solid coverage for about a 270-degree arc. If you have a base station with a good antenna, 25 watts or so, we cover about a 120-mile radius. This gets us to Red Bluff and sometimes up to Redding, and gets us down to the south, well past Stockton, Modesto, and into the west. We get spotty coverage into the Bay Area, and I know I've been able to go out on the Fisherman's Wharf in San Francisco and hit the repeater. We have one fellow in Santa Cruz on a mountaintop, which is about 150 miles away, and he actually gets a good signal in here because, of course, he's on a mountaintop. So let's look at next week, January 17th. We're going to go into the technical aspects of the key components, put some numbers on things, put some interaction on how they work. We'll be looking at things like antennas, types, SWR measurements of antennas, the filters that are used, repeater settings, key measurements, your operating power, and much more. So your assignment for next time is locate one or two models of the 2-meter filter cavities by manufacturer. We use Telewave. There are a number of other ones. So find a cavity filter supplier, download a data sheet, read the data sheet, and get familiar with the terminology that's on it. And also locate and review one or two 2-meter antennas suitable for repeater use. We're using Diamond, which is a economy level antenna. There are a number of them, folded dipoles, that are a better style of antenna. And so do a little research on this for next week. We have an evaluation form that's posted on our support site. So once you log on to Slack, please give me an evaluation to know how this series is working for you. So thank you very much. This is Bill Ragsdale saying goodbye. We'll see you next week.